Again, welcome to today's webinar, Palo Alto Networks, Protection for Security and Compliance. Our presenters today are Matt Lewis, Partner Solutions Architect with AWS, Matt Kyle, Director of Product Marketing for Palo Alto Networks, and Matt McLymans, Network Security Engineer with Warren Rogers. To get us started, I will turn the floor over to Matt Lewis.
Thanks, Heather. Hi, guys. Welcome. So let's get started here and talk a little bit about some statistics around security. So if we have a look at the first one here we've got on the left-hand side, $6.53 million is the average cost of a data breach, according to the CSID, which is actually quite a large, substantial amount of money per data breach. Some other statistics here. So there's been a 50% increase in the theft of hard intellectual property, according to the Global State of Information Security Survey by PricewaterhouseCoopers. The links are available here as well if you want to check out those surveys. A lot of good information in there. But a 56% increase in the theft of hard intellectual property is quite a lot versus last year. And also, according to the CSID again, there's been a 70% of consumers indicated they'd avoid businesses following a security breach. Probably numbers that aren't surprising there, given that if your personal data is breached or given out in a security breach, you'd be pretty upset. So quite some alarming numbers there, but not surprising as well. So let's talk about AWS first and how AWS can be more secure than your existing environment. So in June 2015, the IDC released a report which found that most customers can be more secure in AWS than their on-premise environment. Now, that might be a surprise to a lot of people, considering AWS is classified as the cloud and your on-premise is generally something that you have a lot more control over. But let's talk about that and how that really works. So one of the reasons why we were found, or AWS was found, to provide a more secure environment than on-premises was the breadth of services that we provide our customers, specifically around security, but also the way we eliminate much of the manual effort required with things like logging and monitoring. So we have products and services that help with these things. Also how we simplify resource and access segmentation. We'll talk about that a little bit as well. How we make it easy for customers to do encryption properly. So we have controls, services and functions of our platform that allow you to perform encryption on your data in quite an easy manner. And we also enforce strong authentication of our customers' environments. So things like multi-factor authentication and others to help you secure your environment. So it's almost like we help you with the checks and balances of your platform as opposed to things that might be sitting out there and you're not aware of. So let's talk about the responsibility for security of your platform, and specifically when it comes to AWS. So with AWS, security is really a shared responsibility between both AWS, our partners, and our customers. So if we look at everything below the line here, so the bottom portion of this diagram, these are really the components that AWS controls. For example, our data centers, the physical infrastructure of those data centers, the physical security of our fibers and that sort of thing. That's the security that AWS takes care of, so the physical security. So you could almost say that AWS takes care of the security of the cloud. Now above the line is really where customers deploy their applications. So using things like network security, identity access control, inventory and config, data encryption, etc., to help you secure your application that runs on the cloud. So in contrast to the security of the cloud, which AWS takes care of, it's really the responsibility now of the customer and also partners that can assist, like Palo Alto Networks, to secure your applications that are sitting on the cloud. So an important distinction there. So let's talk about a few other reasons why AWS is so secure. So AWS infrastructure is protected by an extensive network and security monitoring system, or monitoring systems. For example, network access is monitored by AWS security managers daily. So we'll pick up on any malicious activity. We do check for things like port scanning, mass emails, that sort of thing. So we look at any malicious activity that could be happening on the network and report on that. So it's not just a flat network where anything can happen, if you will. We also have other things like AWS CloudTrail, so new products and services that we release or have released to help with your visibility of your security. So AWS CloudTrail lets you monitor and record API calls. So with the console as well, everything's an API call, but anything that's performed in your environment is actually logged. So you can actually go in there and have a look at the logs for when someone spun up an EC2 instance, when someone change the security group, for instance. One point though, don't forget to turn CloudTrail on. I know with my account and my customers' accounts, they've had something happen and they haven't turned on CloudTrail because it's not on by default. So you can check that out through the AWS console and turn CloudTrail on. Then any API calls or any actions that are happening within your environment, you can actually see a log of. We also now have Amazon Inspector, which can help provide you with automatic vulnerability assessment. And that can help with things like security and compliance of applications deployed on AWS. So Amazon Inspector is definitely worth checking out. Alrighty, along with security controls, AWS also has an extensive global footprint that can help when building highly available solutions on AWS. So we now have 38 availability zones across 14 regions. So this can help when you want to build a redundant deployment in different geographic locations, or if you want to build redundancy within a particular geographic location. So really our regions, 14 of them, with Ohio being the newest region in the United States, you can build across multiple regions. So let's say on the east coast of the US or the west coast or in the EU, for example. Also within each region we have many availability zones. So think of availability zones as like fault domains. So shared fiber and power feeds and that sort of thing, all redundant of course, but we group our data centers into availability zones so that you can deploy across availability zones to minimize things like failures within a geographic region and that sort of thing. Alongside with our geographic regions, a point to note here, AWS will never move your data out of a region. So this is something that you as the customer completely manage. So from a compliance perspective, you can be sure that data will stay in a particular geographic region. This is particularly important for regions in the EU, where some countries have very tight laws around the movement of data. So if, for example, you did deploy or move some data or deploy an application in Frankfurt, for example, we wouldn't go and move that data out of that region. That's something that's your responsibility. Alongside these, we also have services like auto-scaling. So the auto-scaling is the ability to scale up and scale down your servers as needed. So you can basically reach or meet your demand as the demand is there. So if you require a lot of demand, you can scale up your instances, and if the demand goes away, let's say at 12 o'clock at night, you can scale down your instances. So this is really important, so scalable capacity in the cloud. We also have a managed DNS service, Route 53. So with Route 53 and auto-scaling, etc., you can build environments that are also DDoS resilient architectures on AWS. So really DDoS moves from being a denial of service to more of a financial aspect where within AWS you can handle a denial of service attack. And because of the large internet pipes we have, because of the ability to auto-scale, because of things like Route 53 and being able to auto-scale and, migrate and have traffic load balance, across multiple sites, a DDoS is now no longer a denial of service. It's more of a how much are you willing to deploy to manage and contain the denial of service. We also have denial of service capabilities, denial of service protection capabilities built into our network as well. All right, so integrating with your existing resources. AWS can also help you improve your security by using many of your existing tools, such as your integration into your on-premise Active Directory. You can also use AWS Direct Connect to provide a secure low-latency extension from your data center into the AWS environment. So Direct Connect is a private line which you can provision into one of our routers, and then you can have this private connection from your on-premise into AWS. Also, many of our services have the ability to provide your own encryption keys if you need to. Remember that if you own and manage the encryption keys, there's no way anyone else can unencrypt your data. So we do offer encryption on a lot of our services, but if you did want to bring your own encryption keys, you have that capability on a lot of those services as well. All right, so lastly here, we have a lot of AWS certifications and are part of a lot of assurance programs. So AWS is certified and accredited by a wide range of regulators and industry bodies, which can help when it comes to gaining compliance for your AWS deployment. Some of these include ISO 27001 for information security management, PCI DSS, so this is quite a popular one, the payment card industry data security standard. So if you are handling things like credit card transactions and the like, there are requirements such as encrypting all of your data at rest and in transit. We can help you do that. We do have PCI DSS workflows running on AWS today. Another quite popular one is HIPAA, which is the Health Information Portability and Accountability Act. So we do have services that adhere to the HIPAA certification or HIPAA certifications. So you can deploy HIPAA certified workflows on AWS. We also have government certifications such as FedRAMP, the Federal Risk and Authorization Management Program. So we do work with the US federal government, and we do also have what's called GovCloud, where you can deploy government workflows that adhere to government standards and certifications. Alrighty, I'm now going to hand over to Matt Kyle from Palo Alto Networks to talk more about how you can secure your AWS environment with Palo Alto Networks. Matt, over to you.
So when was the last time you were on a webinar with 3 Matts? So pretty unique. I am going to talk a little bit about what the VM series next generation firewall from Palo Alto Networks brings to the table relative to security. I'll take about 10 minutes, and then the bulk of the rest of the presentation will be from Matt McClimans on how he is using the combination of Palo Alto Networks and AWS to achieve PCI compliance. Very quickly, we are a little bit about the company for those who might not know who we are. We were just turning over 10 years old. We began shipping our products in 2007. What we bring to the table is a next generation firewall that helps improve your security posture and does things like helps you achieve PCI compliance. The success that you'll see there is on the right-hand side relative to our revenue and our customers. About 3,800 employees, and we are publicly traded on the on the New York Stock Exchange. So let's get into a little bit more detail. As Matt Lewis had mentioned earlier, the cost of a data breach is significant, and let's be very clear: the attackers are targeting your applications and data, and the key point here is that they really don't care where they're located. They can be located in your physical data center just down the hall, or they can be located in a virtualized data center on premises, or even in an AWS environment. The attacker's goal: gain a footprint on your network, and then navigate to their intended target. And that intended target might be to steal data, to use your computing resources to harvest Bitcoin, or to use those computing resources as part of a larger scale threat such as a botnet. And when you're connected directly to a public cloud environment such as AWS, then that becomes part of your network. So that lateral movement could conceivably include migrating to an AWS environment. And that's where the shared security model comes into play. And as you see here in a duplicate image from what Matt Lewis had mentioned, we help protect above the line, if you will. We can help you secure your applications and data in AWS. And let's talk about how we're going to do that. So those who are unfamiliar with Palo Alto Networks, what we bring to the table is a firewall that uses positive security model rules to control what goes in and out of your AWS environment or your network based on applications instead of ports. So if you, for example, if you were to open up port 80 and 443 on a typical network, you're allowing roughly 500 applications based on our own application database that we have to traverse your network. If you now switch and begin enabling traffic based on the application itself, you can immediately begin reducing your threat footprint and reducing the scope of the potential threat. We can then apply threat prevention, such as IPS, antivirus, APT protection, URL filtering to those application flows. So you're now able to apply appropriate threat prevention policies to the allowed application flows. Now, in the image that you see here on the screen, if you are an existing Palo Alto Networks customer, you are able to actually enforce the exact same type of policies that you might have established on your corporate network in the cloud. So that gives you that consistent security posture that can be centrally managed from our Panorama centralized management offering. The last piece that you want to consider when you are looking to move to the cloud is automation of the deployment. When you're operating in the cloud tends to move at a faster pace than things might move on your physical network. So when the cloud team needs to deploy a new application, or the cloud team needs to deploy an update to that application, typically the security needs to be involved, and there is a change control process that security typically takes. This is best practices. This is not an uncommon thing. However, it does tend to introduce some semblance of delay. So what we've done in our VM series product line is included some automation tools that will allow you to deploy fully configured firewalls on demand, as well as some features that will allow you to update your policies as workloads are moved, changed, or updated. And you can go so far as eliminating the physical commit process that typically is required for a firewall to be updated. So what that does is it dynamically updates the firewall as those workloads are changed, and allowing you to minimize the involvement of the security teams, obviously, with their approval. So those are some of the key features that we bring to the table. How the product is typically deployed in AWS, it typically begins with what is commonly described as a hybrid deployment. So you're extending your existing data center into AWS through the Direct Connect link that Matt Lewis talked about, or an IPsec VPN. Either one will work. And both of them have their own set of considerations. And this might be a way to begin moving your application development and testing efforts into AWS, which is a very common use case. The next use case that we typically see happening is the segmentation of the applications to separate applications and data for security and compliance. This falls right in line with some of the topics that Matt McClymans will talk about in terms of PCI compliance. So you want to separate your web front end from your SQL database, perhaps, and you can do that through VPC to VPC segmentation or subnet to subnet segmentation. And again, those policies can be based on the application. So you might have a WordPress server in one environment and a MySQL database or a relational database in the other VPC, and you can build policies to separate those, keep those workloads separate, and in doing so, you're also protecting and preventing the migration of malware from workload to workload. And then the last use case is to be used as a gateway and as a GlobalProtect for remote access use case. So what we see happening in terms of the gateway deployment is rather than backhauling all of your update processes or your traffic through the corporate network and then out to the internet for updates, what you can do is you can build a specific policy for the update process. Excuse me, a little bit of a frog in my throat. What you can do is you can build a specific policy that allows the workloads in the VPC to reach out directly to across the internet to their update sources for those software updates. And then finally, a common use case, particularly with the global footprint that AWS brings to the table, is our GlobalProtect remote access offering. So what the firewall has, in addition to all of the threat prevention pieces that I talked about, is GlobalProtect. GlobalProtect allows you to extend your policies down to a particular device or remote user, regardless of location. And so when you combine that remote access capability with the multiple regions and zones that AWS brings to the table globally, you can now give your employees remote access to your corporate resources very easily and very quickly. As an example, we at Palo Alto Networks are moving all our GlobalProtect users into the AWS environment, and we've done most of the world, and we did so in roughly half a day's worth of work. So it really is a very rapid and easy way to give folks remote access. And GlobalProtect is a key piece of the Warren Rogers, Matt McClymon's story. And then with that, I'm going to hand it, oh, wait, not just yet. I wanted to talk just real quickly about the auto-scaling piece that we recently made available. As Matt Lewis had mentioned, auto-scaling allows you to scale up and scale down workload capacity on demand. Now, as I mentioned earlier, sometimes the firewall team won't move as rapidly as the cloud team wants them to. What autoscaling allows us to do is to eliminate that friction. So what we do is as new workloads are added in the web autoscaling group, we will communicate through CloudWatch using Lambda and CloudFormation templates. We will actually be able to monitor the resources being added and the resource demands. And as those resources demands dictate, we will add a new firewall in the auto-scaling group 1 and 2. They're listed in the middle of the image. So what this does is it allows you to dictate how quickly and how rapidly the firewalls will scale up and scale down independently of how rapidly and quickly your workloads scale up and scale down. So you can set metrics that allow you to determine exactly how that works and how that scaling executes, allowing you to be very efficient and effective with your resource utilization in AWS, yet keeping it secure. Licensing options. There are 2 licensing options. This will be the last slide before we hand it over to Warren Rogers. It is available in Marketplace right now. You can go to your Amazon console and search for Palo Alto Networks. You'll find 3 options there listed in the right-hand side. 2 of them are Marketplace, and the 3rd option is bring your own license for those who want to do it the traditional way. Both the Bundle 1 and Bundle 2 provide firewall protection and then various licensing options, and both the Marketplace bundles include premium support to assist you if you run into challenges while you're deploying, and both of them include a 15-day free trial. So either option is available, and it really is dependent upon what the customer use case is. And the BYOL option is available also for GovCloud. If you're a government customer, the BYOL option is certainly available for you to execute there. Now, I'm wrapped up now. I'm going to hand it off to Matt McClymons. Thanks for your time.
Thanks, Matt. Kyle. So I'm Matt McClimans. I'm the Senior Network Security Engineer here at Warren Rogers, and I'm going to be elaborating on Mr. Kyle's and Mr. Lewis's presentation by illustrating Warren Rogers' specific use case inside Amazon Web Services while leveraging the security products and services Palo Alto Networks provides to reach our corporate PCI DSS compliance. Here at Warren Rogers, I'm primarily responsible for complete oversight of network and security operations while addressing security concerns surrounding PCI DSS 3.1 and SSA 16 SOC 1 compliance for a large enterprise network that includes several thousand endpoints distributed throughout the country. Today, I'm aiming to address some of the concerns and questions you may have about achieving your own compliance within AWS using Palo Alto Networks, and I hope to address some of the advantages your organization can utilize with their products and services. So a little bit about Warren Rogers. We're primarily a service-based organization that provides fuel monitoring solutions for petroleum fueling sites around the country. We give a service to our customers that provides an all-point monitoring system that provides really the most detailed diagnostics into the behavior of the fueling operation at our customer stores. It's a patented system. It provides an array of features including real-time continuous reconciliation technology that's ideal for high-volume sites with automatic tank engagement systems. As seen from the image, we provide an array of reports. It would take an entire 50-minute segment to go through them, but we can provide details about a variety of fuel-related processes, including tank activity, delivery reports, dispenser probe-out summaries, and variance reports, and even some phenomenons like unexplained removals like that. So our data operation, I think it's critical to know the details of our use case and our data flow processes in order to understand how corporate compliance regulations impact us directly. With PCI DSS, although we all have to abide by the same compliance controls, and in my opinion, I believe every organization achieves those controls differently, even though we're all essentially going for the same thing. So to start, this diagram flows from left to right. Here and towards the left, we have our device, which is an OSP. It's an appliance. OSP actually stands for on-site processor, but it's an appliance that runs Warren Rogers proprietary software in order to collect data from a variety of on-site peripherals. The data collected on the OSP is then transmitted upstream to our AWS environment. Once we have the data in-house, we perform extremely powerful computations on the raw data and then produce readable reports for our customers that can be delivered through a variety of means. Something to keep in mind, we have several thousand of these OSPs around the country, and it really does play a critical role because any compliance regulations for a large endpoint network requires detailed implementation procedures in order to prevent really an administrative nightmare for your IT and security teams. So why should you put your PCI DSS environment in AWS infrastructure? When Warren Rogers was considering the public cloud for moving our infrastructure there, we worked with our qualified security assessor, QSA, and realized moving to AWS made a lot of sense for our company because we weren't just looking for a cloud computing environment, but really a complete ecosystem of services, tools, and features that we wanted to leverage. And today we're actually facilitating a very highly scalable and powerful platform. Moreover, since AWS is a PCI DSS level 1 service provider, for organizations out there that process millions of cardholder transactions a year, AWS will always be able to support your environment. And moreover, in the event of a breach, AWS is required under the data security standard requirement A.14 that as a customer of AWS, you can contact AWS and they will actually assist you in forensic investigations. But really beyond PCI DSS, one thing that was a real something we looked at AWS for as a competitive advantage that we believe that they had was Warren Rogers has the conviction that AWS is inherently more secure than an on-premise data center. And what I mean by that is security tools that AWS provides really enable greater transparency and reinforcement of security measures. For example, rather than relying on a network security engineer to rebuild your network infrastructure every time you need to expand capacity, your engineer can actually just build a template of your organization's best security practices. For instance, automating instance creation through Amazon Machine Images can significantly reduce human configuration errors, perhaps accidental oversight of critical configuration steps. So here's a page of major AWS services. I think they're probably the most popular in my opinion. They're all compliant for PCI DSS, and I wanted to highlight how you can use some of them to assist in achieving compliance. If you take requirement 3, for example, which is really just all about protecting cardholder data at standstill. Services like Amazon S3, EBS, RDS are all services that can assist you with the encryption of cardholder data. Specifically S3, your organization can encrypt stored objects using AES 256 server-side encryption really with a couple of clicks. And something that's also important is the data encryption key itself in S3 is encrypted by a master key. And that master key can be set to continually rotate every year, and that's done built in S3 by AWS. Now, to kind of expand this out to requirement 10, which is PCI requirement 10, which is all about logging and monitoring accesses to resources. CloudTrail can assist you with monitoring all the API calls and all of the actions that are performed inside the AWS console. The primary components supported by CloudTrail are log aggregation, alerting, and retention, which are all major PCI requirements. And moreover, S3 can be set to receive and store the log files. Something I just wanted to note is a cost-effective way to comply with log retention for PCI is you can set the CloudTrail S3 bucket for a retention period of 90 days, and then you can archive that older data automatically over to a cheaper platform like Amazon Glacier for a year as the compliance requires. So the PCI challenge for Warren Rogers. So here again we have our OSP, it's off to the left, and it's collecting data from customer peripherals. What we found out is our device was potentially connected to peripherals that store cardholder data. From our perspective, this was particularly alarming because what if our customers were not securely managing the cardholder data? Everyone wants to trust their customers, and we do trust our customers, but we wanted a solution where we can guarantee our device, the OSP, was only being accessed by Warren Rogers personnel, and our device was only receiving the data it needed to receive. So ultimately, the question we asked ourselves, how can we protect ourselves regardless of our customers' networking and security environment? So some challenges. We were previously non-compliant. We had thousands of remote devices. All of our customers had implemented our box differently within each of their environments. So we broke it down to several questions that we wanted to answer. First, how do we secure transmission to AWS? How can we ensure that all of the data being sent to AWS will always meet and exceed PCI DSS data transmission requirements? We did not want to have to update boxes individually when encryption standards changed by the SSC. Second, how do we know if our customers are inadvertently sending our device cardholder data? Not that we think that they are, but in the event that something is configured incorrectly at the site, we don't want their cardholder data. How can we ensure that's not being collected on the OSP level? Third, with all of these devices, how can we ensure our boxes are running the PCI DSS required applications and features? How can we find out if a specific site or a specific OSP is not running the applications that it needs to be compliant? And lastly, how can we standardize access to OSPs? And what I mean by this is how can we have one access method to manage our boxes to perform maintenance? And how can we control this access with the tightest security regulations without having to ask our customers for a VPN or a third-party access method? So what we had, so we have 3 customer networks here, A, B, and customer network N. Each one in this example has 3 OSPs, and each OSP has a customer-assigned IP address. So we would send all of our data to our centralized on-premise data center using a couple methodologies, TCP for real-time, a daily FTP transfer. But now the problem with this is that every time we wanted to send a different form of data out, we'd have to have a conversation with our customer security team to request it, and so they would actually have to poke another hole in their firewall for us. Additionally, all of this was going to an on-premise data center, which is inherently a single point of failure. Lastly, and this was kind of a real pushing point for us, is we had to manage VPN clients for each customer, meaning a customer would give Warren Rogers an access method to manage the OSPs. Some of the access methods were good, some, in my opinion, were not. But the problem was managing the customer VPNs because we had so many access methods. How do you manage all of them, and how do you track the individual IPs for each customer for each OSP? And moreover, how do you, some of our customers were very good at giving VPNs out to very specific users, but what's preventing that VPN from being given out to other users that we don't want them to have? So what we wanted, this was kind of our Cadillac dream solution, is we wanted to consolidate all of the data streams on the OSPs to a single stream for inbound and outbound transmission to a number of redundantly configured gateways in AWS. We did not want to have to poke holes in our customers' firewalls every single time we wanted to perform data operations or open up a new data operation. We wanted the data streams to be encrypted using the best encryption methodologies available today. And lastly, and most importantly, we wanted to control all access to the OSPs with the highest security settings. We wanted to do this with a jump server or gateway server, or some people in the industry call it, that would act as a single access point to the OSPs. The jump server would allow us to control who's gaining access to the OSPs, when they're gaining access to them, and most importantly, what actions were performed when they gained access. So everything I just described in the previous slide, we achieved with Palo Alto Networks and Amazon Web Services. And specifically, I want to highlight how we're using GlobalProtect with the encryption profiles and host intrusion prevention profiles, or HIP profiles, the LSVPN, or large-scale virtual private network, to reduce data latency, increase redundancy, and increase our global presence. And lastly, use the incredible access policies that the Palo Alto Networks platform provides using user ID, application ID, content ID, and data filtering. So the GlobalProtect use case, off the bat, we're using it in a very unique way. We've installed GlobalProtect on the OSP to connect to the Palo Alto Network gateways hosted in Amazon Web Services. You can, as Matt Kyle was talking about, you can use GlobalProtect in the conventional way to manage real users as well, connecting to your Amazon environment. GlobalProtect gives us the opportunity to send data to really any server behind our Palo Alto Networks platform and use application ID to ensure that only the authorized applications are in use. With pre-logon, we can ensure that the connection stays up and is in continuous use and cannot be disabled by anyone with access to the OSPs. So those are just some benefits, but some more detailed benefits. User ID is something that comes natively with GlobalProtect, and it allows us to assign a unique identification to the OSPs. It allows us to see how much traffic a specific OSP is sending, what kind of traffic is being sent, and if the data that's being sent is of Warren Rogers' corporate interest. Moreover, we can quickly apply unique policies to each OSP from the Palo Alto Networks firewalls. And with GlobalProtect, we know that we're currently meeting and we're exceeding PCI DSS requirements. From the Palo Alto Networks firewall, we can centrally set encryption standards for all the GlobalProtect connections. We can kind of sit back and be rest assured that since Palo Alto Networks is a major player in the security industry, that they will always provide best industry practices for encryption and will always beat what the Security Standards Council comes out with in the future. Just a couple more things. GlobalProtect creates a virtual interface on each OSP. With that virtual interface, what it allows us to do is we do not need IP assignments from our customers to manage the boxes. In fact, we really don't care what that IP is. Instead, we can just use the virtual interface that has its own IP associated with it to be managed by the firewall. And lastly, HIP checks and LDAP segregation. I'll be talking about that in the next coming slides. So host information and policy enforcement, or HIP, is something that's unique to the Palo Alto Networks GlobalProtect software. HIP more or less ensures that the required security applications and vulnerability patches are installed on the OSP. It can range from really anything, firewall status of the endpoint, data encryption standards on the endpoint, is antivirus running, patch manager, does it have the most updated patches, and the way you can use it is if the endpoint is connecting to your Palo Alto Networks firewall, if the endpoint does not meet all of the HIP check requirements, you can actually set it to a sub policy with less access, saying, and then generate an alert saying, oh, endpoint 5 is not running antivirus. Go and investigate and see why, and then you know that it's out of compliance, and you know that it does not have the same level of privileges as it would if it were passing its HIP check. So data filtering for cardholder data, this is something that is natively built into the Palo Alto Networks platform. And it was a major selling point for us because it allowed us to ensure no cardholder data was being sent over the GlobalProtect streams. Once you make your cardholder filtering profile, it can be applied to any policy the Palo Alto Networks platform is using. For example, a very common use case that I can imagine is if you are collecting cardholder data in your environment and you want to ensure it never leaves a specific server or specific network, you can add that cardholder data filtering profile on the firewall policy to alert and to ensure that cardholder data is never leaving that environment. And I think if you show your QSA that once when your validation period comes around for PCI, it will make them very happy to know that, hey, this is our firewall policy that is ensuring cardholder data is not leaving our environment. And something I'm going to elaborate more upon is probably the most important aspect of PCI is network segmentation. That's something that I think using the Palo Alto Networks platform you can really leverage. So next, the LSVPN, or large-scale VPN. Here's a map of the United States. I've roughly placed the Amazon Web Services data centers in Virginia, Oregon, and California. Next, we have our geolocated OSPs. They're not in nice bubbles like that, but for illustrative purposes, it works. And then next, we deployed the VM series firewall in the Virginia data center, for example. And after that, we didn't want to route all of the OSP traffic to a single firewall. What we wanted to do was have them set up satellites off of it and then connect those satellites back through the LSVPN configuration. Now, this is very flexible on how you want to set this up. You can get very creative with it, and it's very easy to use. But then we still have the OSPs, and with GlobalProtect, we can connect to the nearest gateway based on a round-robin time. So in the event that we have some OSPs down in Arizona, and one of the California satellites go down, they'll automatically fail over to the second California satellite, and so on and so forth. So we can always guarantee to our customers that we have a continuous flow of data, and we can always provide our services for them. So quickly, just a little bit about ADS and group policy. Since the boxes are now, or the OSPs are now part of our network, we can really apply group policy, and we can apply detailed application ID on each one of them. Since we do run proprietary applications, you have the opportunity to put in custom applications to say, yep, the OSPs can only run, whatever application we're running. But then if you use GlobalProtect and you want to use it as an actual user, you can really say, oh, users who are connected to GlobalProtect can only run, whatever applications you want them to run. They can't go out and run something that's malicious. And since they're connected to our network with group policy, we kind of say, touch one, configure many. You can just apply group policy to all of the OSPs quickly. And the way group policy works is, you can have a default PCI policy that all of your endpoints have. And then if you have, if we have a customer that wants a particular policy set on the boxes, we can do that for that customer, and then we can even get down to the specific site level. So quickly, just a little bit about the deployment. This is kind of a textbook deployment for the Palo Alto Networks firewall. You need three things. You need an AWS VPC, public and private subnet, and EC2 instances to protect. Next, you deploy the VM series firewall inside your VPC. Give one interface to the public subnet and one interface to the private subnet. You'll have to set up the route inside Amazon's VPC to ensure that all the traffic is traversing the VM series. And then when it's set up, you can tune the VM series to protect you from all the network threats that are out there, which is really where I think obviously the strength of the VM series comes into play. And then kind of a hidden benefit that I think a lot of people don't look at is you have the ability then to simplify EC2 security groups. You can kind of have a base policy for all of your instances inside your network because all of the policies are ultimately being controlled from the VM series. So making compliance easy with Palo Alto Networks, really what compliance comes down to, the way I broke it down, is three things: least access control, logging and flexibility, and segmentation. Least access control with user ID and Active Directory or however else you're authenticating your users. You can apply policies directly on the VM series to allow specific users or groups access to your resources. You can provide your assessor the proof of the policy controls. Logging and flexibility with the Palo Alto Networks platform, what Matt Kyle was talking about with Elastic Beanstalk and the expansion of the platform. You can continually grow your platform seamlessly. And then lastly is segmentation. In my opinion, is the most important aspect of compliance. If you reduce your scope of your network, you're going to reduce the cost of compliance, and then you're also going to reduce the threat. So the more you can segment it out, that's what you're going to achieve. This is just a simple example of how it can break out if you don't segment. So on the left, you have a flat network, and when your assessor comes in to assess your network, all of those machines are going to be in scope for compliance. On the right, if you segment everything out, which you can do easily with the VM series, it's going to be much easier to achieve compliance when you work with your assessor saying, yeah, these 3 or 4 servers are in scope, and that's all that they have to assess, and everything else you can be far more flexible with the non-cardholder data environment. So just some quick tips before I go. Reach beyond PCI requirements for security. If you don't have a security policy within your organization, I think PCI, even if you don't want to meet compliance or you don't need to be compliant, use PCI as a baseline. Also, even though PCI looks at it as kind of a one-size-fits-all, and every organization is different. If you just meet PCI baseline, in my opinion, it's not the best security approach. Always continue to grow beyond the PCI requirements because you don't know what's going to come out a year from now from the SSC. And then, avoid expensive mistakes. Involve a QSA, a Palo Alto Networks engineer, and all your team on major design decisions. And something to go off of on what Matt Kyle was talking about and Matt Lewis was talking about is the cost of cardholder data compromise is always going to be greater than the cost of PCI compliance, both financially and reputationally. And then evaluate whether or not you can eliminate the reasons for necessary compliance. Ensure that the benefit of touching cardholder data is greater than the liability. Meaning, if you have 4 transactions a year, it might make sense to outsource it and go with a third-party application. And lastly, I think compliance with and without Palo Alto Networks in any environment, whether it's Amazon Web Services or on-premise, is really uncertainty in compliance versus certainty in compliance. And I think when you leverage application ID, user ID, and content ID with the cardholder data filtering policies, you can be very certain that you're not only meeting compliance regulations, but you're also. So I'm going to pass this back off to Heather for Q&A.
All right, thank you so much to all 3 Matts for a great presentation today. On your screen, you will see 4 polling questions. Please provide us with your feedback by clicking on the radio button that corresponds to your reply. We do have about 9 minutes left, so please feel free to continue submitting questions, and we will start addressing some of those that have been submitted. We do apologize in advance if we're not able to get to all of them. And with that, I'll pass the floor back over to Matt Lewis for the Q&A session.
All right, thanks, Heather. Very informative. Thanks, Matt. So first question we've got here, and I think this one might be for Matt Kyle. So how are you different, or how are you different? How do you complement security groups, and how are you different, or how do you complement WAFs?
Sure. Yeah, the security groups and WAFs are both services that are available through Amazon Web Services. In fact, as most of you probably know, security groups is a requirement. And security groups and WAFs are some basic security functionality, and the way that we complement both of them is we bring to the table the application visibility and the application control. So the ability to see within that traffic flow the different types of applications that are flowing into your Amazon environment by name. So you can set policies, for example, based on SharePoint. SharePoint is one of the most common deployed application in Amazon, so we can say allow SharePoint and deny everything else. So we bring that level of visibility to the table, and then we add to it the ability to apply threat prevention policies, so blocking threats within those application flows and controlling file movement. Those are three of the key features over and above security groups. A WAF, oftentimes you'll see a WAF sitting right beside a next-generation firewall. A WAF is a web application firewall typically designed specifically for public-facing web applications. And so they are only going to be focused on HTTP and HTTPS applications, and that is their sole role. We look across the entire network for all types of applications. So you might see commonly both solutions deployed depending on the customer use case. As another example of our complementary nature, Imperva, one of the more common web application firewalls, is actually also a customer. That should answer the question.
Alrighty, thanks, Matt. We've got another two questions here around PCI compliance. So, does your IPS satisfy PCI requirements, and is your firewall PCI compliant?
Yeah, PCI compliance. So the answer is maybe, right? The PCI compliance is a combination of technology and best practices. So our firewall does address the firewall requirement in the PCI DSS listing. The IPS can be used to provide the threat prevention capabilities that are required in the PCI DSS listing. Whether or not you pass compliance is going to be entirely up to your best practices, how you implement them, and then the interpretation of your QSA, your auditor. So, it's very difficult for me to say that we are compliant because of all of the different factors that come into play. So make sure you're involving your QSA, as Mr. McClymont had mentioned several times, in your PCI efforts.
All right, and thanks, Matt. We've got another question here about auto-scaling, how that works and how it's related to licensing. I can take this one. Unless, Matt, you want to take it?
Well, I think it's relative to, we both should take it, Matt. It's probably relative to the firewall licenses, but why don't you explain your side and then I'll explain my side.
Sounds good. Okay, so auto-scaling. Well, auto-scaling is basically a trifecta of services. So it's the Elastic Load Balancer, CloudWatch, working together with the auto-scaling service itself. So what basically happens is you set a trigger in CloudWatch, which is the ability to monitor metrics on the instances themselves, so monitoring something like CPU utilization. If the CPU, for example, goes above 60%, you would then trigger the auto-scaling service to spin up another instance, which would then bootstrap and get attached to the Elastic Load Balancer and get put into service. So it's really a grouping of services that help you to scale out. If, let's just say, an instance is overwhelmed, you can scale out by a number of instances to help that instance out. Matt, do you want to talk about the licenses and how that works?
Yeah, so what we can do then is we can take some of the metrics that Mr. Lewis just described and feed that into the firewall. We can monitor them and then fire up a firewall license. The way that licensing would work is you're going to be using the marketplace licensing, and you're going to build what we would call a bootstrapped image of that firewall that you're going to want to be deployed. And then when the metrics dictate the bootstrap image will kick in and be automatically deployed in the auto-scaling group that you may recall in the image. And we will be using the either bundle 1 or bundle 2 license from Marketplace so that the license can be automatically activated, if you will. Typically what we see happening is customers will use the annual bundle option for the base firewall deployment. And then for the scaling, for the firewalls that might need scaling, you would choose the hourly. That would be the most cost-effective way to take advantage of our firewall licensing model, so that you're only using the necessary resources and costs as the traffic demands dictate. Now, this also may answer Basil's question about the use of the load balancers. Basil, take a look at the auto-scaling solution that we posted on the AWS section of our website. I think it will address your requirement to address the IP limitation that you mentioned in your note. So we have solved that through the auto-scaling integration. Auto-scaling is fully supported by Palo Alto Networks, and it was jointly developed with AWS's assistance.
And Matt, I think that also answers the question, is it possible to create redundant Palo Alto firewalls in AWS?
Yeah, it does. It does allow us to do that. Traditional active-passive HA is supported natively by the VM series, but from a cloud-centric point of view, the auto-scaling offering is probably the more common approach. So take a look at both of them and see which best fits your needs.
And Matt, I think there's one last question here. How can we get in contact with you? So who should I contact to get help designing AWS web applications?
We can take that offline, and Heather, let's give that person my email contact and then Matt Lewis's contact so that we can get that continue that effort.
Okay, sounds great. So it looks like we've wrapped up with the questions.
Yep, over to you, Heather. Thank you.
All right, thank you so much to all of our presenters for taking time out of their day to bring this presentation to us today. Thank you to our audience for taking the time to join us today, and enjoy the rest of your day.